Hi everyone, thank you for hearing my presentation. Now I'm going to introduce my project, the Apply Deep Reinforcement Learning on Caro. And my name is Phạm Das. I'm from case 14 AI and robots. I want to introduce actual characteristic networks. Given state is reporting to the actor or policy network, it takes the action t at time t, and the actions time t generate put the actions and generate the states at time t plus one, and result in the reward at the time t plus one, and this is the inputs put in used to train the critic network or value networks. This value network it will predict the value, and the value is used in the advantage function. The advantage function is into to reinforce the action more intelligent, and used to the in the loss function. And then here we introduce the principles of the actor critic algorithm. The first step would sample the states and action are from the policy, and we fit to fit these states to the model to estimate the return. We sample a sum of return, and then we the we get a return we use to calculate the advantage. So in the next step we use the gradient descent to we gradient the loss function, and then the fifth the the five step with step 5 we improve the policy by update the parameter, and then we back to with the new parameter, go back to step 1, and we generate this new sample in the model, and then we update parameter, we get the optimal policy. And on actual critics algorithm and learn post the policy and the value state value function. The value function is used for the both trapping, updating the state from the subsequent estimate to reduce variance and accelerate learning. And so it's the same with actual critic algorithm, but with post the discount factor in the advantage function. We interested with near step in the future, and we don't care about the far step in the future. So there are the two network architecture. The first one, this is a separate policy and characteristic network. It's more parameters and more stable in training. With training policy network and training characteristic network. But in the architecture in this slide, we share feature and less get more or less parameter. We have a backbone is CNN with the extract feature, and then we have a two hit. The one of which is the value hit, which is the regression and renders the values, and the other one is the policy hit. You get which predict the action, and it's hard to find a good coefficient to balance actor loss and the critic loss. And so and to introduce the Caro competition. So given the Caro environment, we have the 10 bars, and we have 5 consecutive pieces horizontally, vertically, or diagonally will be uh, will be the winner. So as you can see in the slide, and this state in here will be flattened by multiply 10 to 10, and we get the 1D dimension 1D dimension numpy array with 10 multiply 100 dimension. The reverse in the environment here is -1 if the engine acts on the board, and -20 if the engine acts on the furious action, and furious if the engine acts in the first stage, and it's -1 when you the engine acts on the furious stage, and plus 100 if win is the engine and get win, and with there's no point if two engine is draw, and the game is draw. So this here I'm gonna to do my model is I'm prepare reinforcement learning models. I have a two model is a vanilla actor corrected network. The actor network is with two fully connected layers with hidden inside the 256 and 256. The output layer is a 100 which rep 100 or the number of actions. The characteristic network is the same the actor network with two fully connected layers is the 2.6 and 256, and the output layer is 1 which is or the values, and the CNN actor characteristic network I built the backbone CNN to extractor as extractor, and with 4 conversion to the with the filter it's a 10, 12, 20, 20, and 25, and the kernel size here is a 3. The action here is the one fully connected layer is the 2056, and the output layer is the number of action is 100, and the critic hit is the fully connected layer is the 2056. The same with the action head, and the output layer is the 1 as named values. In this project, we practice with 2 experiments which one is training 2 engines with base actor characteristic networks, and the second is the training 2 engines with 2 types of the actor characteristic networks. Which one is the actor characteristic, and the other is CNN's actor characteristic network. We trained 2 engines with 300 game, and with testing the batch size is equal to 32, the epoch is equal to 16, alpha is 0.003, is gamma or discount factor is 0.99. The log function used in the project is the mean square error or MSE. The optimizer is the ADAM function, and all experiments are practiced with the same setting. So this is the result, and we have some discussion. The score of the reward As you can see in the figure 4, training performance of two engines. To reach the score of the reverse of CNN actor critic engine higher than a normal actor critic engine. So because we trained two engines at the same time, it means that two engines have learned while playing together. And we use the reverse in these two areas to the engine. We change, so it's next, as you can see in the finger 4.p. We changed two engine with normal actor critic network. So you can see the performance of both are not good. The average score of the reward of the engine 1 in total game is minus 887, and the average score of the reward of the normal actor critic engine 2 is minus 264. So we have to have guess higher score the master engine. So in the conclusion here, in this project we use a different type of deep learning model. So we find that the deep reinforcement learning can learn and self-learn how to play the game of checker or of Gomoku of chess, but are still limited in decision making. We made the engine plays game against with other team engines in the checkerboard on the Caro board competition. My engines have won over other engine, but the decisions are still suboptimal. In the future, we train the engine with smarter and more optimized. In addition, we also want to develop this engine that can play many different games and without having to change its way. But to improve the engine, we must do more experience and hyperparameter tuning, or to train rewards or train target networks and so on. And this project would train the reward score and train the target network like CNN actor critic network. It have gotten some positive results, but the engine needs more time to learn. And in the future, we aim to create the engine can play not only Caro game, but also we play chess and tracker, Sudoku, and many. Thank you for hearing my presentation. If you have more questions, please comment or please send me the question. I'm very glad to answer this question, and thank you so much.